Hi everyone, it's Alyssa and welcome to You Can Learn Math. Today we're talking about logarithms. Logarithms, or just logs, are one of those things that come up in your math journey. And for a lot of people, they are met with a big, what on earth is going on? If you are one of those people, I'm with you. I have never liked logs. But I do understand them, so I'm going to do my best to help you get to that point too, because they can be a little, I get it. Okay, so logs and exponents are two sides of the same kind. Same coin. Same kind? Same coin? Same coin. So if I had 2 to the power of 3, if that was my math problem, the math question is, what is 2 times 2 times 2? 2 times itself 3 times equals what? And we would answer, that equals 8. Okay, so that's an exponent. A log is asking sort of the inverse of that. If I'm given this problem, it's a variation of that, but it's asking how many times do I need to multiply 2 by itself to get to 8? And I would say 3 times. I multiply 2 by itself 3 times to get to 8. So that's how they're connected. So if I have this right here, if you have this sort of setup, it's log base x. That is the base. And this is, log base x of y is how most books present that. I've heard it read a couple different ways. Most teachers will say log base x of y. Log base 2 of 8 is what? So if you're trying to put it into exponent terms, it's x to the power of what equals y. That's how they're connected. So that was here. 2 to the power of 3 equals 8. And if you're like me, when your teacher first introduces that, or when you first watch this video, you're probably wondering, why? Why is this necessary? Well, it's because there are things like this that all of us, I think, can do. We can do that. We can figure that out, even, with or without a calculator. Like if I was told 5 to the power of 6 equals what? If I didn't have a calculator, it might take me a while, but I could do that math, right? Say 5 times 5 times 5, and do that 6 times. You go, okay, 5 times 5 is 25. 25 times 5 is 125. And then, I might get to a point where I start writing it out, but I could get to 5 to the power of 6. I could solve that. However, there are going to be logs you cannot solve. I hesitate to say cannot when you're talking about math. You cannot solve easily, we'll put it that way, on your own without a calculator. Like if I said, what is log base 3 of 5? So if I'm asking that, I'm saying is 3 times itself how many times equals 5? And you might go, well, wait a minute. That's not possible because we have 3 to the power of 1. That's 3. 3 squared is 9. Yep, 3 to 9. That could be 5. It can be a decimal. So you can have this and it will be a decimal. It will be in between 1 and 2 and it will be a decimal. And you will need to use your calculator to do that. Now, most of the time, when we just see log by itself, it's very, very common for you not to see a base. Be like this, log of 100. Like, wait a minute, you just said it had to have a base. Well, when it's just log, we're talking about in your math class, there are some real-world exceptions to this that I'm not going to get into. But in your math class, when you see log, that means base 10. 10 times itself how many times equals 100? 2. Or in exponent terms, 10 to the power of 2 is 100. The other one that's very common to see is, LN. That is natural log. And that is base E. E is a constant, Euler's number. Euler is, E-U-L-E-R apostrophe S, Euler's number. And it's just a constant, like pi is a constant. Most math classes, you don't really get into where the number comes from. You just have to use it. It will be in your calculator. So natural log is base e. It will not be written. The e will not be there. It is base e. Yeah. Honestly, in a lot of math courses, especially when we're talking with high school level math, you don't usually get into much about, what e is and how to use it other than using it in natural logs and log base e. For those, aside from a couple of ones like, say, natural log of e. So that's saying e to the power of what equals e. Well, any number like this, it would be to the power of 1. So something like that you wouldn't need a calculator for. The majority of natural logs, you're going to need your calculator for to calculate those. So the two most common, again, that you're going to see in your math book for just log will be a log where they are providing you with a base, whatever that base can be. It can be anything. So here, 4 times itself how many times equals 16? 2 times, or 4 to the power of 2 is 16. And here, log with no base is, in your math book, base 10. If it's not provided, assume it is 10. And the final sort of thing I'll ask with this, or most people ask with this that I'll try to answer for you is, why would you want to use this? You want to use this because there are times when you're trying to solve for that exponent. It's solving this. Like if I said 3 to the power of x equals 51. How would we solve that? How would we do that? There isn't a button on, most calculators that would let you do this easily. Especially not in the older calculators. In the olden days, those calculators, they did not have that. So logs are a way to do this because you can ask that question. It is 3 to the power of what? 3 times itself how many times equals 51. You put that into your calculator, you can solve that, and you have your x. You have that answer. So it's a way to solve this kind of equation. Are there other applications of this? Yes, of course there are. But we're talking about for your math class. This is the application that you are going to come across the most often. All right, so on to the next video, which will be all of the rules that apply to logs. Hey guys, if you'd like more math courses, study guides, test prep, etc., head to mathwithalyssa.com. And if the video you just watched was helpful or useful in any way, please let YouTube know so I can keep helping you and others like you. Comment, like, share, subscribe. You know the drill. Thank you so much for stopping by. Hope you have a great day. See you later. Bye.